Hello students, welcome to Yupp Master. Good evening. Today we are discussing about that relative refractive index of a medium and the relation between critical angle and the refractive index of a medium. So first of all, let us take some problems which are related to critical angle and the refractive index. So in the previous classes we have discussed about critical angle and the relation between critical angle and the refractive index, that is sin C is equal to 1 by mu. Now today we are going to learn what is relative refractive index. So refractive index is a term related to two speeds. One is a speed of light in vacuum, another one is speed of light in a particular medium. Alright. Now the ratio of the two speeds that gives the refractive index, that is speed of light in vacuum, speed of light in a desired medium for calculation of refractive index. So if you want to know about the refractive index of a particular medium, you need to know about that speed of light in that medium. Already we are having the information about speed of light in vacuum. So in that medium you need to know about that refractive index. In another way, if you are going to talk, the speed of light in all the materials is not same, very clear. It is going to identify that sometimes the speed of light is identified different materials. Now if you are taking that the speed is going to be reduced how many times, number of, if you are going to take that one number, it is going to be reduced by one number. So 1 by mu times the speed is reduced. So refractive index is the one phenomena which gives a significance how many times the speed of light is going to be reduced in that medium. Yeah, 1 by mu times that of the speed of light, 1 by mu times that of the speed of the light. If you are going to take that 1 by mu times that speed of light in a medium, then you can estimate the speed of light in glass or water, whatever it may be. Suppose if you are going to take refractive index of glass material is 1.5. So simply the speed of light in the glass material is reduced by 1.5 times, that is 1 by 1.5 into 10 to the power of 3 into 10 to the power of 8 meter. Now you will get that 2 into 10 to the power of 8 meters. Suppose if you have taken that water, the refractive index of water medium is 1.33. The speed of light in the water medium is identified 2.25. It's very clear, 2.25 into 10 power 8 meter per second. So in all the way we are going to talk about that refractive index gives the relation between the speeds of light in different media, that is in air medium and denser medium. Right, have a look. So we need to take the problems based on the critical angle. The refractive index of a medium is 2, the critical angle of the medium. Yeah, you need to identify that. Just first of all take the relation, that is relation, that is sin C is equal to 1 by mu. So, here you can take that C is the critical angle, mu is the refractive index. Yes. So, it is going to be find out mark. Now, what about that mu value? That is mu root 2. Therefore, sin C is equal to 1 by root 2. C is equal to sin inverse 1 by root 2. You will identify that C is equal to 45 degrees. So, the critical angle is having the relation with refractive index, that is very clear. Now, you have been identified this 45 degrees. This is a general problem based on the relation between C and mu. Right. Let us go for another problem. Yeah. Find the refractive index of water if the critical angle for the water air interface is 48.75 degrees. So, in the given problem you are going to find out that refractive index of water by having the critical angle. Please take the given data. What are the options? That is 1.33, 1.50, 2.33 and 1.03. So, please take that. Critical angle C is equal to 48.75 degrees. Yeah. Therefore, refractive index mu is equal to question mark. So, by knowing the relation sin C is equal to 1 by mu, we have to take that mu is equal to refractive index mu is equal to 1 by sin C. So, that is equal to 1 divided by sin 48 degrees. So, if you are taking that sin of 48.75, that value is estimated 0.75 approximately. So, this is the approximate value. Now, you will find out that is equal to 100 by 75. Let us take that conversion, 25 fours and 25 threes. That is mu is equal to 4 by 3. You are getting the value, mu is 4 by 3. It was approximated 1.33. So, the option is first one, that is correct. By knowing the critical angle, easily you can calculate that refractive index. For any material, it is going to be calculated. Next one, if the critical angle for the light travelling from the transparent glass to air is 41 degrees, then refractive index of the transparent glass. Same method that we can apply in the previous case also. So, take that. Yeah. Therefore, you can take critical angle C is equal to 41 degrees, mu is equal to question mark. Therefore, sin C is equal to 1 by mu, that is the existing relation between C and mu. Now, take that sin 41 degrees, that is equal to 1 by mu. You can find out that mu is equal to 1 by 41 degrees. Yeah, sin 41 degrees value is going to be estimated, that is, you will find out that sin 30 value is 0.5, around 0.5. So, if you are going to take that more than 0.5, suppose it is going to getting that 0.6 some value, that is 1 by 0.6, let us assume, yeah, value is 6. Now, you will find out that mu value is approximately 1.5. Yeah, by doing the calculations you can get that 100 by 66, you will get that approximate value 1.5 something, you will get that. So, this is the correct answer. Now, take that next problem. If the incident ray falls on the surface of the glass slab, then there will be no bending of light ray. So, this is a good question to discuss the phenomenon of refractive index and density and the angle of incidence. 3 points we have to take that. Whenever light enters from one medium to another medium, if the densities of the two media is going to be same, then there is no refraction. So, the uniform density is there in case of the two media, that is the light ray incidented, there is no bending. Then if you are taking that, angle is also one criteria. If you have normal incidence, that is the light ray has been incidented normally on the transparent surface. Let us see, yeah, perpendicularly, normally, incidented, inclined angle. At an inclined angle it is not correct. Inclined angle other than 90, that goes for deviation. So, this is also correct, this is also correct, both A, perpendicularly and normally. Yeah. In case of normal incidence, there is no deviation of light ray. What are the other possibilities? If the two media, first medium and second medium, having the same density and the refractive index is also same, then only there is no bending, there is no deviation of light. That is very clear. Now, you can go for the next one. The refractive index of a medium is to the critical angle. Simply you have to take that sin inverse of 1 by 2. Yeah, we will confirm, that is, this is mu value. Yeah, you will find out that mu is equal to 2. Yes. Now, critical angle C is equal to question mark. Simply sin C is equal to 1 by mu, C is equal to sin inverse 1 by mu, that is sin inverse 1 by 2, yeah, sine inverse 0.5. So, it is going to be 30 degrees. Please have a look, 0 degrees, 30 degrees, 45 and 60. So, this is the correct option, please take that. Yeah, let us go for another problem. Yeah. Calculate the critical angle for a diamond having the refractive index 2.2 and crown glass having the refractive index 1.52. Now, you can take that this is mu diamond is equal to 2.42, mu crown glass is equal to 1.52. From the previous case, that implies theta c, let us assume critical angle theta c is equal to sine inverse 1 by 2.42. Here also theta c is equal to critical angle sine inverse 1 by 1.52. Now, this is all from relation, that is sine theta c is equal to 1 by mu. This is from the relation only we have, where theta c is the critical angle. Then you can easily go for the calculations in case of diamond, that is theta c for diamond is equal to, yeah, you will find out that 1 by 2 point, that is sine inverse 100 by 242, let us assume. So, that is equal to sine inverse 0.4, you will get that 0.1000, it is going to be divided with the 2.22, that is 0.4, and after that you will get that 1. So, after calculation you will get that, yeah, sine inverse 0.413, it is about 0.413, it is near value of the angle 20, yeah, if you know 0.5 it is 30 degrees, but it is less than 0.5. So, the angle is less than 30 degrees, that is you will find out that theta c is approximately 25 degrees, but while you are going to take that calculation with the help of this, now crown glass, the theta c value is nearly 25, we can have that some estimation. Crown glass, that is theta c is equal to that is 1 by sine inverse 100 by 52, you will get this, yeah, you get that sine inverse 0.66 approximately. So, the value is around 40 degrees, more than 40. So, you may have that 40 41 degrees, I think so. You will get that 41. So 41 point some value. So we will get that approximately 42 degrees. Like, let's see that options. Yeah, by looking into the options, easily you will get the estimation, but you are not having the any instruments to calculate that angle. Sometimes you are not allowed to get the calculator. So how you will estimate that angle of incidence or critical angle? After all the calculations, you have the idea. Suppose sin inverse 0.413, that is going to be around 25. Just you should keep in mind, that is very useful. That gives the quick response in entrance examinations and related to other problems also. Yeah, here you will get the 0.66, it is more than 0.5, right. It is going to be at around 40, nearby 40. So from the given options you can estimate that. Yeah, this is the correct answer. It is very clear, right. Let us go for another problem. Yeah, relative refractive index of a medium. The term relative, it is the comparison. Relative is the term which is going to have the comparison between the two parameters of the same kind. That is, if you are going to take velocity of a moving objects, two moving objects, you will get the relative velocity. If you are going to take the density of the two medium, that is, you will get that relative density. So relativity, it is going to be comparison, it is going to have that some common observation into two parameters. That is, you can take that in the case of refractive index of first medium and second medium. So in the refractive index phenomena, the refractive index of that one medium is going to be identified with respect to another medium. So whenever light enters from one medium to another medium, the refractive index of the second medium with respect to the first medium is known as relative refractive index. So easily you will find out that for medium 1, its refractive index is mu1, medium 2, its refractive index is 2. When light enters from one medium to we will find out that this is also one medium. The light rays are going to be entered from one medium to another medium. This is a normal. The light rays are when light rays are allowed to enter from one medium to another medium, the refractive index is going to be considered with respect to the first medium. So the refractive index of second medium with respect to the first medium is known as relative refractive index. So if you are going to take that in the reverse case also, light enters from second medium to first medium. then you can express the refractive index of the first medium with respect to the second medium. It is very clear. Now, if you are going to take that one parameter, that is mu to 1, refractive index of second medium with respect to the first one, easily identified that. Sometimes you can take that mu 1 2, refractive index of the first medium with respect to the second medium. So, this is also possible. Let us see the possibilities. Here we are going to take the combination of different media, that is of having the different refractive index. It is very clear. Yeah, light is allowed to enter. Yes. So, yeah, first one is rarer medium, second one is denser medium, and third one is also rarer medium as compared to second one by having the refractive index values. In this case, you can easily take that relative refractive index. When you take that these two, refractive index of the second medium with respect to the first medium, easily identified that. Please take that. You are all going to take that these two, that is mu 2 1 is equal to mu 2 by mu 1, that is 2 by 1, easily identify that. In this diagram you can observe one phenomenon. Light is going to be incidented from rarer to denser medium. Yeah, with respect to the normal, it is going to be refracted in a one direction. Here, from denser to rarer, it is going to move away from the normal. You are going to take that. This is the normal. It is going to move away from the normal. Again, it's identified that. But here, the case we are talking about relative refractive index. Here, yeah, with respect to these two medium, this is going to be mu 1, this is going to be mu 2. Can you estimate that relative refractive index? This medium is identified with this refractive index mu 2, this is mu 1. Easily you will find out that refractive index of the second medium with respect to the first medium, that is mu 2 by mu 1, that gives the mu of 2 1. So, easily you will calculate that. If you want to express the relative refractive index as the ratio of the refractive index of the second medium and refractive index of first medium, when the light rays are entered from first medium to second medium. Please take that. This is the case, we are going to take that. So, yes, easily you will find out that the refractive index of the second medium with respect to the first medium is called relative refractive index of that medium. So, it is identified as mu 2 1. When light moves from one transparent medium to another transparent medium, air or vacuum, then relative refractive index of second medium with respect to first one is defined as, that is mu 2 1, that is mu 2 by mu 1, or sometimes you can take the reciprocal also. This is a reciprocal. Identify that. This is the relative refractive index of second medium with respect to the first medium, that is mu 2 1. Let us take some examples we have taken. This is of two transparent surfaces having the different refractive index. So, light is allowed to move from one medium to another medium. Yeah, this is of first one and second one. Light enters from first medium to second medium. Then you will consider that relative refractive index, that is the refractive index of the second medium with respect to the first medium is known as relative refractive index, and it is going to be identified mu 2 1 is equal to mu 2 by mu 1. It is very clear. For better understanding, you will take that this is a glass material, this is another transparent material. So, light enters from one medium to another medium having the different refractive indices. So, we can solve the problem, right. Let us go for the examples, easily you can identify that. Yeah, you can talk about that mu is the ratio of the speed of light in vacuum to speed of light in the medium. Now, let us go for mu 1, that is C by mu 1. So, what is V1? Speed of light in the first medium. Speed of light in first medium. Yeah, that is very clear. So, C is the speed of light in vacuum. That is very clear. If you are going to take that mu 2, that is C by V2. While you are calculating the relative refractive index, consider the speed of light is also one parameter to calculate the relative refractive index. From these two equations, this is the first one, this is the second one, you will get that mu 2 by mu 1, that is relative refractive index. Relative refractive index Ri, that is mu 2 1. Relative refractive index is identified as a mu 2 1, that is equal to C by V2, C by V1. So, you will find out that V1 by V2, V1 by V2. If you know the speed of light in a medium 1 and speed of light in a medium 2, then you can easily find out that relative refractive index by getting this one. Now, let us have look. Yeah, if the speed of light in first and second medium are represented by V1 and V2 respectively, then we can easily find out that mu 1, mu 2 relation with V1 and V2 with respect to the speed of light C in vacuum. Easily you will identify that. Yeah, let us take that one example, you can have the better understanding. Take that example. When a light ray moves from water to glass, the refractive index of glass with respect to water, yeah, that is clear. The light ray enters from water to glass. The refractive index of glass with respect to the water, so, enters from. So, you can take that. It is represented by mu g w. So, this is the refractive index of glass, this is refractive index of water. Easily you will find out that 1.3 by getting the calculations. Now, you can take that the light enters from glass to water also. In that case, you will find out relative refractive index. So, whenever the light enters from one medium to another medium, you can have the possibility to calculate the relative refractive index with respect to the first medium. Now, it has been expressed mu 2 by mu 1. So, whenever the light enters from water to glass, the refractive index of glass with respect to the water is known as relative refractive index. Simply, the refractive index of second medium with respect to the first medium is known as relative refractive index. That is very clear. Let us take that one more example. Yeah, you can take that. When a light ray moves from glass to water, as compared to glass and water, the refractive index of glass is more as compared to water. That is given. Let us assume this is mu 1, this is mu 2. Light enters from first medium to second medium. Simply, the light rays are allowed to enter from denser to rarer medium. In that case, you need to calculate the relative refractive index. That is, you can easily identify that refractive index of the water with respect to the glass is known as relative refractive index. That is 1.89. That is, in the previous case, you have identified mu g respect to water, that is 1.13. This is case 1. This is case 1. In case 2, mu, that is 1.89. In the two cases, what you have seen, light enters from water to glass. Yeah, you will water to glass. Light enters from glass to water. This is light enters from rarer to denser. Here, glass to water, light enters from denser to rarer. The relative refractive index is going to increase. In the first case, it is 1.13. In the second case 1.89. Yes, it has been entered from water to glass. Generally the refractive index of glass is going to be 1.5. In that case it is 1.13. In that case the refractive index is going to be 1.89. It is more than that of actual value. So the light rays enters from denser to rarer and rarer to enter rarer to that denser. You may have that difference in the relative refractive index. It is going to be increasing. You have to find out that. Some questions are going to be framed in these two cases also, based on that rarer to denser and denser to rarer. That is very clear. You can easily find out that. Right. Let us go for another question. Problems. So the refractive indices of a two different materials has given, that is glass and water. Let us take that really. Yeah, this is a 3/2, this is 4/3. The refractive index of glass with respect to the water. You have to find out that. So, yeah, from you will find out that, yes, light enters from water to glass. Now you can take that refractive index of glass with respect to water, that is identified mu G and W. You can take that. Yes. Now you can take that mu G by mu W is equal to. So they have given this is mu G and this is mu water. Now you can take that 3/2 whole divided by 4/3. Just you can take that the ratio and its simplification, you will get that 9/8. That is the case. Let us see the options. Yeah, this one is correct. They have given the refractive index values in terms of the ratio, and you need to take the division and its simplification. Finally, you have been calculated that value, that is 9/8. It is very clear. Now let us go for another problem. Yeah, here they have given the velocity. The velocity of light in air and the glass is 2 into 10 power 8. The refractive index of glass with respect to the air. In this case, they have given, you need to find out that the refractive index of the glass material with respect to the air. So light enters from air medium to the glass medium in this case. So you will find out that is V air, that is 3 into 10 power 8 meter per second, that is V glass, that is 2 into 10 power 8 meter per second. Now, you need to find out that refractive index of glass with respect to the air. You can guess that the light rays are going to be entered from air medium to the glass medium. So, the refractive index of the second medium with respect to the first medium is nothing but relative refractive index. Here, the case light enters from air to glass medium. So, you need to calculate that relative refractive index. That is mu g with respect to air, mu g with respect to air. Very simply you will find out that, do that, is equal to mu g by mu air. You know one relation, general relation, mu is equal to C by V. Now, we will take that in case of 2, therefore, mu g by mu a, and that is of mu g and a is equal to that. So, we will take that C by Vg, C by Vg whole divided by C by Va. Yeah, if you are going to take that from this one, you will write down mu g is equal to C by Vg. This is the existing relation. So, from this one only. At the same time, you will find out that mu a is equal to C by Va. This is very clear. Now, finally, you can cancel that. This is Va. Yeah. You will get that Va by Vg, that is equal to 3 into 10 power 8 meter per second whole divided by 2 into 10 power 8 meter. Yeah, you will get that cancellation 1.5. You will get that 1.5. 1.5 is the answer. Please take that options. Yeah, 3 by 2 also, they are going to get that directly 3 by 2. They are expressed in the ratio. This is the correct answer. Please take that. In this way we can solve that. Simply they have given that refractive index of glass with respect to the air. It has been solved with the help of this relation only. This is very, very important. This relation mu is equal to C by V, mu g is equal to C by Vg. C is the common, we have to take that cancellation. That is, so if you are going to take that this ratio, finally we will calculate that. Let us go for another problem. Yeah, light ray moves from glass to diamond. What is the refractive index of diamond? Simply you have to find out that mu diamond with respect to glass. Refractive index of diamond, that is mu d by mu g. So, it is C by V d, right, C by V g. Finally, you will get that V g by V d. So, the speed of light they have given in glass, they have given in take that. You need to calculate that V g by g, that is, what about V g value? 2 into 10 power 8 meter per second, that is 1.25 into 10 to the power of 8 meter per second. You will find out that value. Yeah. Yeah, 5 by 8, that is 1.6. Exactly, you will get that first option. This is the correct one. In this way, you can solve the relative refractive index of a material with respect to the first one. So, please have a look into that continuous effort. Please keep the continuous effort to have the better improvement towards the competitive examinations, and that gives the very good improvement. Keep watching that EdMaster continuous classes. Thank you very much.